Hey, this is a part two of our showcase. In the part one, you saw the overview of a platform, and then how we have done the field testing, few basic stuff, and then in part two, it's more oriented towards to show the feature about the monitoring, how the analog data is being used to calculate the system parameters, and then in turn control the system as such. Right? So we'll be starting the motor. This is the then. It got just started. So that's the motor that's running. So right now it's been configured, and then you can see it gets to the on state, and then it's in auto mode right now. Can you let's go to the shutdown option. It's been configured to the second option, which says that have the operator to confirm before starting after shutdown. Fine. The system has been configured to formula is defined in such a way that the formula of this device, which is controlling the motor, is on this one. It's a simple equation right now. It's been defined as A0 is less than 34. But actually, if you see the motor, it's running at maybe I'll just go down. So it's running at a current of 2.3. So which is nothing but less than 34. Right? So it's just a formula that we have defined right now to monitor the bad state. Now, based on the formula, it considers the motor is running under bad state. We'll take sample size of the sample size is 4, and it's an interval of 20 seconds each. Yeah. So we would probably expect around 1 minute to take for the motor to shut down. Okay. And in the meanwhile, we would see few data parameters that are being displayed on the device, which should be of some importance for using. Yeah, so that's the display on the device that you are seeing. Fine. So it has got few codes which are useful for us to see what the system is, and you could probably hear the motor turned off because we had 4 bad readings as per the sample. And we got a okay, and then we got an amperes reading that you can see that the analog data that's being sent to the system. So that's the continuous analog reading of 16 recordings that we are sending to the server. Fine. So right now the motor went to a shutdown state. Since it's been set to never. The operator has to come back and confirm. Now if you can have the operator to go down to the system, then you can turn it on. It's an off state that you can see right now. And when it's turning it on, it will ask for a shutdown reason why the motor was shut down. Probably the operator could say that there was a fuse breakdown. You can give a reason, and then based on the reason, you can have that particular record made so that people can refer back and then understand what really went wrong. And what was action taken by the user before we continue to start the motor again. So in this case, it's a plant, it's a system itself. So I'll say yes, and it takes some time. You could see that for the action to take place. So there is a delay in the system to respond, and that's intentionally made so that the operator has got enough of time to really validate things, and then he can go ahead. Otherwise, the action can also take you very immediately. We don't want to do it because these are huge plans in real time, and it will really take good amount of logic and thinking before the action is really applied. So that's the cause for the delay. Otherwise, the system can take care of it very immediately. So that's one of the wonderful features that we saw now. So apart from that, user can also decide not to have it in auto mode, and probably would just set it to a manual mode by doing an uncheck of this parameter, and then that would in turn let this motor to keep going on even though if it's got a bad data. Fine. So that could be another feature that would the developers the operator would be interested in. So let me go to the other parts of the system now, wherein this is the dashboard, and you would get a nice minute by graph to get to know what happened. Sorry, I didn't select the right place. Yeah. So you could see that there's a nice graph that's depicting the three different parameters that current parameters and the voltage parameters that we have in the system for the user. To let him know that this is what is going on a on the last hour is 24 hours, right? So on the last 24 hours of the system, now the system was really behaving. So that gives it nice feedback to the user. And also there are a few other parameters within the system. What it does is it gives a nice control over the events that are happening within the system, such as for this one, if you go here, you can define a notification or you can define an escalation. Probably you would come here and you would say that if the number of times a fault has been detected within the system is 60% of a specific control, then probably send a notification to a specific group here that you would have defined in the system. Fine, and you would save it. So what happens is, if the system detects it 60% of the time of the 4 samples, then it would start to send a notification to this particular system. Again, we had 4 different bad readings, and then we could see that that particular motor is shut down automatically. And it goes to a manual state till an operator puts it back again. So we had a bad formula, or sorry, we had a lesser value put. That's the reason it is trying to take control of the motor. Otherwise, it seems to be fine. So similarly, you can also see an escalation. So in case of escalation, how many times the motor really shut down is very important. Maybe in this case, a manager above the operator would be really interested to know, to see what's happening within the system. So you would rather probably come back and question what is really going on and what is the action taken by the operator. So this is another way of sending notifications to the operator himself or to even the supervisors. So this is very important because that gives you the entire system control. So example say this one. So this is another very important feature that we don't generally try to exhibit, but point is, there is a password that's being calculated every time there is a for every few seconds. So what's happening is, if the device has to come back the next time, it needs to be aware of this particular password. Only then that particular unlocked data would be accepted by the system. Otherwise, probably it would be considered as a person whom we don't know, and that particular unlocked data would not be considered within the system. So that's another very important feature from a security point of view that's being implemented within the system. Okay, and then we have few other features. In the meanwhile, let's go ahead and then start the system. Okay? Yeah. So there is type 1, type 2, type 3 devices that we have. So this is actually a type 1 device which has got 16 analog inputs and 4 digital controls. Similarly, we have type 2 device which has got 8 analog inputs and 8 digital controls. And we have a type 3 which is totally the entire system is all the 8 bits or all the 16 bits would be digital outputs, and the user can control them as per his will. So type 3 is what is this one? Sorry, type 3 is this is the one. So wherein you would see your devices and you would have a direct action on it. So because these are direct systems wherein you want to just control the on and off of it. You don't need any other monitoring system or any other feature. In the future, we are also planning to add scheduling so that you can also have a feature to control it. And this more largely will be used by house appliances or probably commercial appliances. And that's where this type 3 device will be more concentrated on. And type 1 and type 2 is more industrial focused, and we want to cover that area. So overall, what I've done so far is I've demonstrated the potential and the field testing that we have done with this type 1, type 2, type 3 devices of IoT platform that we have done. And here is the exhibition of the platform that we have done so far.
And now that you've seen the system, as part of the onboarding process, we have a few steps that people who are interested could really follow. So one is you need to register the device with the factory. So probably if you decide to go with us, you can give us a call or drop a mail there under our contact us. We would get back in touch with you and then probably describe the product more and understand your requirements. So once you have the device registered within our factory, we would have it installed on your devices on your system. And then the device can be customized further, and then you can start to monitor your applications. We also have few other flavors. We can also provide total customization of the software and directly have it installed on your hardware or your platforms or your company itself. Now the point is we need to really understand and work out along with you guys to understand what your requirements, how to make it happen. There are many other features within the platform which are not fully disclosed here, such as integration between multiple devices. They can intercommunicate with them, and also there is an option to enable a child and a parent relationship. Some of the companies do have a requirement that don't want to shut down their system until unless the secondary system is shut down. Fine. So such kind of combinations of intercommunication between devices are there within the system, just that it'll get out based on your requirements, and we can also work out on our pricing and the cost. Please do get in touch with us by using the contact us menu that you have there. We can take it forward from there. Thanks for listening to me.